morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honest Geometry class. Today we're going to be talking about special right triangles. I am actually super excited about this lesson. I know, I'm a big dork, but this is really cool stuff, really good stuff, really important stuff, okay? This, I promise you, like many things in geometry, are going to be on the SAT, on the ACT. This is also going to be a very important factor for you when you take trigonometry, okay? These two special right triangles are going to kind of be the cornerstone of most geometric calculations. And the first special right triangle we're going to talk about is the 45, 45, 90, okay? First thing, hopefully everyone understands and sees immediately is that a 45, 45, 90 is what kind of a triangle? It's a right triangle, yes, but what kind of a right triangle? It's isosceles, thank you. Since these two base angles are congruent, that means that the sides are congruent. And we're going to call those sides x and x. Okay? Now, if we did the Pythagorean theorem, which we could, you could find the value of the hypotenuse. But that gets very tedious, okay? When you have a 45, 45, 90, there's a specific way that the hypotenuse is always going to end up. And I mean always, guys. There's no ifs, ands, or buts about it. When you have a 45, 45, 90 triangle, both sides are equal, hence we call them both x. And then the hypotenuse will always be that x value, that side value, in other words, times the square root of 2. Always. 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 I'm going to show you how this works in a second. Now, I'm going to show you all the possible scenarios, but I learned through a lot of different SAT and ACT preparations that whenever you see that you have a hypotenuse that has a whole number attached to it, it's easy if the hypotenuse is, for example, let's say the hypotenuse was 5 radical 2. My x is 5, correct? So that means that would be 5, and that would be 5, and done. You're done with the triangle. It's nice and easy. However, if the hypotenuse is a whole number, you're going to have to set up an equation, which I will teach you, I promise. But you may want to learn this. If the hypotenuse is a whole number, the legs will always be that exact whole number times the square root of 2 over 2. Why is that? Because you're going to have to rationalize. I'm going to show you the why behind this in a second. You have my word of honor. But I want you to try to remember, for sure remember this. There's no choice here. This is one of those that you have no choice. Now, if you want to go a little bit above and beyond and you really want to help yourself and you really want to save time on quizzes and tests and ACTs and SATs, remember that if and only if the hypotenuse is a whole number, the sides will be that whole number value times the square root of 2 over 2. You don't have to memorize that, okay? This guy right here, you do not have to memorize. Does it help? Sure. But you do not have to memorize that. And I'm going to show you why now in a second. You've got 3 different scenarios here, brothers. First scenario, they're going to ask you a lot of times these kind of problems. They're going to say, solve the triangle. By solve the triangle, we know that already. We know what that means. That means find all the angle measures and find the side lengths. Okay? In this particular case, we know it's a 45, 45, 90. And they gave us a hypotenuse of 3 radical 2. Well, you got to memorize that the hypotenuse represents the side length x times radical 2. So what's the side length here in this particular case, guys? So this is 3, and this is 3 as well. Done. Bye-bye. Have a good day. It's that simple. When they give you the hypotenuse in the perfect form with radical 2. Another very easy scenario that they can give you. They give you a 45, 45, 90, and they give you one of the side lengths. Well, guess what, guys? Since it's a 45, 45, 90, you know that both sides are congruent. So what does x equal? 6. And what would the hypotenuse be? 6 radical 2. You guys are awesome. Perfect. Why, Mr. Morrow? Because the hypotenuse of a 45, 45, 90 triangle is that side length times radical 2. You feel me? Okay, now, here's the part that gets everyone into trouble. I'm not going to do the shortcut first. I'm first going to do it the long way. And then I'll show you why and how awesome that shortcut really is. In this particular case, gentlemen, they give you the hypotenuse to be 5. Now, a lot of times, people will go, oh, this is 5 square root of 2. No, wrong. Please don't do that. Remember the formula. The hypotenuse has a formula of x radical 2, does it not? Don't I need to solve for that x, that side value? You guys with me here? So we solve for x by dividing by square root of 2. And then I have 5 square root of 2. But guess what? I can't have a radical in the denominator, as we know. So we must rationalize. So we're going to have to multiply square root of 2 over square root of 2, giving us x being equal to 5 square root of 2 over 2. So this side length will be 5 square root of 2 over 2. This side length will be 5 square root of 2 over 2. And that's the mechanics behind this. Yes, sir. Yes, that's the whole beauty of this shortcut up here. If you remember that every time that you have a whole number as the hypotenuse, you simply multiply that whole number by radical 2 over 2, you don't have to go through all this work. You can automatically say, oh, wait a second, that's a whole number? Oh, yeah. So this is 5 radical 2 over 2, and this is 5 radical 2 over 2. I'm not going to penalize you for knowing the value of that. I'm not going to penalize you for being awesome. But I wanted to show you the mechanics. You know how things are, guys. Geometry is a lot of different formulas. You may forget one day. As long as you don't forget the why behind it, you're fine. But heck, if you want to memorize both sets, both possibilities, oh my God, you're going to have virtually zero work on these homeworks and quizzes and tests. Virtually, for these particular questions. Does that make sense, guys? And does this whole shortcut thing make sense to you? Since I got to divide this guy by radical 2 anyways, that means I have to rationalize. So I'm going to multiply by radical 2 over radical 2. And remember that whenever you multiply a radical times the exact same radical, you get the radicand. So that's why you multiply the hypotenuse value when it's a whole number by radical 2 over 2. Does that make sense? Promise? So again, you don't have to memorize that part, but you sure as heck fire have to memorize this. You got no choice there, brothers. None. Does that make sense, guys? Any questions on that before I move on? Promise? All right. Awesome. Thank you. Okay, now. Okay, let's try that again. Okay. Now, next. There's a 30, 60, 90 triangle. The good news, that's it. There's only 2 special right triangles. Now, the 30, 60, 90 is not as easy. Well, let me rephrase that. That's the wrong way to say this. It is easy. It's not just as super duper easy because you're going to have 3 actual different side lengths. Okay? Oh, and one thing I should say. One way to memorize this, I always did. Don't you have 2 sides that are equal and 2 angles that are equal? So that's why you're multiplying by x times the square root of 2. That 2 represents 2 equal sides, 2 equal angles, in my head. That's why I always remember that. Okay? In this particular case, gentlemen, the 30, 60, 90, you've got 3 different side values. Okay? And if you remember the angle-side relationship theorem, the smaller the angle, across from that is the smaller the side, correct? So since the 30 is the smallest angle here, the side across of the 30 is the smallest side, which we call x. In a 30, 60, 90 triangle, I promise you, the hypotenuse is always 2 times the smallest value. So we're going to call that bad boy 2x. And the side across the 60 is always the small side times radical 3. How do I personally remember that it's a radical 3? Don't I have 3 different sides and 3 different angles? That's how I remember the difference between, oh man, which one has the radical 2, which one has the radical 3? Square root of 45, the hypotenuse is x radical 2 because there's 2 equal sides, 2 equal angles. The side across the 60 is the small side x times radical 3 because there's 3 different sides, 3 different angles. You feel me here? Now, very similar to the hypotenuse being a whole number in the 45, 45, 90, when the when the side opposite the 60 is a whole number, oh, I messed it up. I messed that up. Let me put this here. Wow, the effect kind of lost itself there. Wow, I kind of feel like, boo. That was horrible. You know what? I'm not even going to accept that. Oh, wow. Okay, well, boo. All right. When the side opposite the 60 here, guys, is x, okay? The other 2 sides will be their normal formula times the radical 3 over 3. So what does the normal formula mean? Well, across the 30 is just x, the smallest side. Okay? And then 2 times the smallest side. Okay? However, whenever you have the 60 as a whole number, the smallest side now becomes that 60 side times radical 3 over 3. Okay? You with me there? I'm going to show you how and why that works as well right now. There are a few more scenarios for this kind of a triangle. Let's do the first scenario, the easiest of them all. When the side across the 30 is 6, that's my small side. That's my quote-unquote x. That's my small side, though. So my hypotenuse will be the small side times 2, which is 12. Done. My side across the 60 will be my small side 6 times radical 3. Done. If they give it to you in that form where they give you the small side, you just plug them into the formulas. It's pretty simple. Scenario 2, they can give you the hypotenuse. Now, isn't the hypotenuse twice the small side? So if the hypotenuse is 14, what would my small side across 30 be? 7. Now that I know my small side, what would my side across the 60 be? 7 square root of 3. Pretty simple there as well. Okay? Another simple scenario. They can start out with the small side, with the side across the 60 being in regular form, 8 square root of 3. If that's the case, what is my small side across the 30? Just the 8, right? Because remember that the formula for us across the 60 is the small side times square root of 3. So my y would be 8. What would my hypotenuse be, which is twice the small side? 16. So those 3 are the easy, fun scenarios. Okay? Now, the more challenging scenario, unfortunately, this is just the way it goes. Sometimes they're going to give you the side across the 60, as a whole number. Just remember the formula. The side across the 60, which in this case is 9, equals the small side times radical 3. How do you solve for x, the small side? Divide by radical 3. So then, now I must rationalize, correct? But when I rationalize, I'm going to get, in this case, 9 square root of 3 over 3. So do you see now how the trick works? I'm multiplying square root of 3 over 3 to both the small side and the hypotenuse. You with me here, guys? Talk to me, guys. Okay. So, in this case, we could reduce this, and this becomes 3 square root of 3. So that's my small side. What's my hypotenuse at that point? 2 times that. So it'd be, come on, Moral. So that'd be 6 square root of 3. So, how can I use this as the trick format, or just the easy way? Well, if I know that my side across the 60 is 9, my side across the 30 will be that 9 times radical 3 over 3, which reduces to 3 radical 3. Then I multiply that bad boy by 2, which gives me 6 radical 3. That's kind of messy. 6 radical 3. Again, do you need to memorize that trick? No. And honestly, with no sarcasm, I really don't care if you do or not. It's really no skin off my nose. It's more for you, for your speed, for your accuracy, okay? You don't have to memorize the trick, but you have to memorize the base foundation. You with me here, guys? All right. Not that bad, right? It's actually quite fun. This is the enjoyment part, absolutely. Okay. May I continue? Because we're done with learning. Now we're going to apply it. Let's go ahead. Thank you, my brother. What's going on with this? I just want a single page. Okay, let's try this again. And we're going to pause. Okay, guys, we're back. All right. So I want you to solve this triangle. First things first. What would angle A be? Angle A would be 30 for sure. Okay. What side did they give me? The side across the 30, the 60, or the hypotenuse? The hypotenuse. So what would CB be? 5, half of 10. Very good. So CB would be 5. And what would the side opposite the 60 be? Or in other words, AB? AB would be 5 square root of 3. Very simple. Pretty easy. Does that make sense, boys? Simple, right? May I continue? Let's do it. Oh, wait. Come on, Moro. There's one on the bottom. I'm sorry. I messed up. All right. How about here, though? The side across the 60 was given to me as a whole number. Does anyone remember the trick? I know we just learned it, but does anyone remember the trick on how to figure out the small side? Yes. I'm going to take this 6, and I'm going to multiply it by radical 3 over 3. So that means that my small side is 2 radical 3. Remember, angle D here will be 30. So this is 2 radical 3. What would my hypotenuse be then? 4 radical 3, because it is twice the small side. Now, if anyone is out there saying, oh my God, I don't understand this trick part. Fine. Remember that the side across the 66 equals my small side x times radical 3. Divide by radical 3 to both sides. 6 over square root of 3 equals x. I've got to rationalize. So I multiply square root of 3 to top and bottom, which gives me 6 square root of 3 over 3, which equals 2 radical 3. And that is my x, or small side. You can do it the long way. I really don't mind. But darn it, Isn't it a lot easier just to remember the trick? But that trick only works when the side opposite the 60 is a whole number, or for the 45, 45, 90, when the side opposite, when the hypotenuse is a whole number. You with me here, boys? All right. MOPR is a square. Find MP. Okay. Please remember here, guys, that if MOPR is a square, angle O is a 90, correct? Don't the diagonals of a square bisect the angles? So this would be a 45, 45, correct? So that means what would OP be? And then what would MP be? 9 square root of 2. Have a good day. Pretty simple, right? Okay. And last but not least. Now, this time I gave you a hypotenuse that was 4, correct? What would I do using our trick that we learned? How do I find the side value here in this case? Yes, sir, my brother. Well, my x is the 4, right? Beautiful, son. You are on fire, son. 2 square root of 2, 2 square root of 2. Again, for anyone in the audience or sitting out there in the virtual world saying, dude, I just don't get that. Do it the long way. 4 equals my sides times radical times square root of 2. Divide by square root of 2 to both sides. 4 over square root of 2 must be rationalized. This will equal 4 square root of 2 over 2, which equals 2 square root of 2. That's my side x, and that's how I got 2 square root of 2 for both sides, because it's 45, 45, 90. And of course, angle x here would be 45 degrees as well. But that trick, I'm telling you, saves time and frustration and lives. Okay. That's what one of my boys said. Okay. Guys, I hope you learned a lot. Thank you very much, and have a wonderful day. Bye-bye.